This tutorial is on how to add two vectors that are at right angles to one another. While running cross country, Hunter Adams runs 8 kilometers east and then turns to run 7 kilometers north. What is Hunter's displacement? Now, displacement being a vector includes both magnitude, which is the size, and the direction, which is the angle. So we want to write our two vectors, and when we draw our two vectors, we draw them tip to tail. So first Hunter runs 8 kilometers east, so we'll draw an arrow representing 8 kilometers to the east. And we try and draw things as proportional as possible. We have another vector that is 7 kilometers north, so we draw an arrow that is at the tail. The tail of this arrow is to the tip of the first one we drew, and this one is a little bit smaller than the first one that we drew, and that's 7 kilometers north. Now, our displacement vector is from the tail of the first vector to the tip of the second vector. So that is our displacement vector, our size, and our direction. So because they're at right angles, we can use Pythagorean theorem to get our d, which is our hypotenuse. So we'll write that out here. D squared is equal to 8 kilometers squared plus 7 kilometers squared. And so we solve here and we get that d is equal to 10.6 kilometers. Now, being the hypotenuse, it should be the largest of all the sides. We also need that angle. So over here we'll say that we're finding the angle. Now, to get the angle, we're going to use our inverse trig functions. So we'll write out our SOHCAHTOA, where the sine is the opposite side over the adjacent, or the hypotenuse side, and the cosine is the adjacent side, that's the side touching that's not the hypotenuse, divided by the hypotenuse, and the tangent is the opposite over the adjacent. So in this case, we are going to use the inverse tangent because we know the opposite and the adjacent sides. So to get the angle, we take the inverse tangent, that's the also called the arc tangent. It's a tangent with a -1 on it. And we want the opposite over the adjacent, so we want 7 kilometers over 8 kilometers. Make sure that your calculator is in degree mode, and so we get our angle to be 41.2 degrees. Now, this is sufficient if you prefer to just write it as really two solutions, the magnitude and the direction. The picture shows which angle we're talking about, but I like to write it all in one. So 10.6 kilometers, put a semicolon here and show my angle. So my angle looks like this with respect to the x-axis, which is 41.2 degrees. We could also say it's 41.2 degrees north of east. I find that a picture is a little easier than writing and figuring out north of east.